Again, I'm recording. All right, so we looked at just now at the metric system. Now, here we're going to look at something similar, which is basically temperature. And there's really two units of temperature we're going to consider. There's Celsius and there's Fahrenheit. There's actually a third one, I think, called Kelvin that comes up if you study, I know it comes up if you study physics, but that's a different story. Now, is Celsius or Fahrenheit, are they part of the metric system? Honestly, I don't know, but I do know that this country, the United States, we use Fahrenheit. A lot of the other world, many countries in the rest of the world use Celsius. Okay. Again, why do we use Fahrenheit? I don't know. We just out of habit. But you can convert between them. You can convert between them. You know, from Celsius to Fahrenheit, and from Fahrenheit to Celsius. And this is actually how you do it, using this equation. The idea here, as I just also put, F is the temperature in Fahrenheit degrees, or degrees Fahrenheit. C here is the temperature in degrees Celsius. And using this equation, that's how you convert from one to the other. So it's not like what we've seen before, where you do a unit conversion, meaning you multiply by a fraction. It turns out you can't do that here. But here what we're going to do instead is we're going to use this equation. That's what we're going to do. Okay, well, let's do an example. Now, I guess you could take this as a given by either observation or whatever, but water freezes at 0 degrees Celsius. That's what this notation is, this little 0, that's an exponent. It looks like an exponent. Well, that stands for degrees. The C here is Celsius. So this is 0 degrees Celsius. It turns out water freezes then. Water also boils at 100 degrees Celsius. Again, here's this little 0 meaning degrees. C means Celsius. So we can determine when water freezes in the Fahrenheit scale. All you do is you replace our C here with 0, right? If you go back, we had this equation. We're going to replace this C here with 0. Doing so, we get this, which is 32 degrees Fahrenheit. So we get 32. The degrees Fahrenheit we put on at the very end, this is what we get. Or you can write it out in words like this. As you can see, either one is right. You know, that is writing it this way or writing it out in words. Okay. All right. For water boiling, same idea, except now, where we had 0, we're going to put 100. Since water boils at 100 degrees Celsius. So we plug that in and we do the calculation. We get 212 degrees Fahrenheit. Okay, that's what we have here. So just a basic example to get our feet wet, so to say. All right. Anyway, let's keep going. So here we're going to convert this temperature, -23 degrees Celsius, to Fahrenheit. And again, it's really just using that equation, as you can see. From before, we can use that equation. Again, we just replace C in this case with our temperature in degrees Celsius, which in this case is negative 23. So we plug it in and we do our calculation. And you get negative 9.4. So in other words, negative 23 degrees Celsius is the same as negative 9.4 degrees Fahrenheit. So we get this, as you can see, which I wrote also like this. We have negative here, so same thing. Okay. All right, so I hope that makes sense. Now let's do another one. So here's one I want everyone to try. Basically here, this one's going to be a little bit different because now I'm giving you the temperature in degrees Fahrenheit, and you want to convert it to Celsius. So here again, we have this equation, right? But here I'm giving you what F is, and you have to figure out what C is. So take a minute or two to do that. It takes a little bit of algebra. It's not too bad though. So hold on, let me just pause the recording to let everyone